My project is a multi-body collision simulation using spatial partitioning. As part of this project, I implemented a spatial partitioning system which could detect collision among multiple bodies uh, in a faster way than a naive method which would detect collision uh, when compared to across each and every body. Some of the interesting stuff that I implemented as part of this project was making a circle using only STL. Basically, I used geometric equation of the circle and filled in a circular fashion. Developing a collision resolution system. In this, I implemented a impulse method, which would calculate the normal vector and calculate the impulse and apply it to both the circles. I assume an elastic collision, but my method can definitely be changed to something like an inelastic or partially elastic collisions. So third thing and the main part of this project was the collision detection method. So there's a naive method which can basically checks collision for one body with all the n-1 bodies, and it keeps on doing for each and every body. So it's basically O(n) square. A spatial partitioning method where I actually divide the uh, our search space into fixed number of grids, and when we can search in these grids are basically collisions. So this method does not search for each and every does not depend on comparing with each and every other body, rather all the circles which are in that particular grid or in that particular cell. Mm, In my case, since these are fixed number of cells, it's not really dynamic in nature, but there are better ways to implement this using, say, a quad tree, which which would divide the cells, uh, which would divide the grid in number of cells as required. Okay, and so having said that, let's go into the simulation. Uh, I'll run for 1000 bodies, and you can see a lot of collisions happening, and all the collisions are being resolved, and you can see a lot of circles colliding with each other. Now as you increase, you will see some determinant in speed because the bodies are increasing. But if I make it the naive way, you'll see that it's more slower than your spatial partitioning method. And we actually calculate the time it takes uh, to run one iteration of frame. And in this case, this is around 42 milliseconds. But if we don't use the naive method, which is and use the spatial partitioning, you'll see that the time is reduced around 22 milliseconds, thus proving our point that spatial partitioning is obviously more efficient. And I actually made a graph which would compare the speed of each iteration as we increase the number of bodies for the spatial partitioning and the naive method, and we can clearly see the difference as we go on to higher number of bodies. Now this is what I had for my project for collision detection. There are further developments that can be made to this project is we can add different other kinds of bodies. In this case, I have used only circles because it's very easy to detect collision between two circles. But we can definitely have polygons or rectangles and detect collision against them. Right now, we are using a fixed grid system to detect to make a spatial partitioning, but we can definitely use quad or KD tree to make it more dynamic in nature and thus making it more efficient. Right now, all the collisions are in 2D, but we can definitely just add another axis and maybe some modification to make it in a simulation in 3D. So this is what I had for my project. Thank you.